Okay, so this is the first problem of today's Atcoder contest. And in this problem, we are given that Takashi likes full moon. So basically on the first day, he's going to, so like right now, it's the day one. And on the first day or on or after today, on which he will see the full moon is like mth day. So first day on which he'll see a full moon is the mth day from today onwards. And then after each consecutive p days, he'll see a full moon. So first day is m, then afterwards it's m plus p, and then it's m plus 2p, and so on. So we have to count how many days he'll see this full moon between 1 to n days inclusively. So just give me a second. So we can either solve this using some modular arithmetics, but if we look at the constraints, see, n and m and NMP are all less than or equals to 2 into 10 to the power 5. So we don't have to do any mathematics. See, let's start. Let's say like currently our day is, let's say it's M. And then while our current day, like the day on which we are currently, if this current day is less than or equals to N, we'll add 1 to our answer. And we'll keep incrementing current by P for all the next iterations. And finally, we can print our answer. So this will work because the constraints for this problem are very low. Is it okay? Yes, no, anything?
Yes, sir.
Okay, is anyone having any doubt in this? Okay, so I'll show you the implementation. Okay, this is not the implementation. This is the implementation. So in this, I'm taking first N, M, and P as input. Then, like I said, instead of maintaining another variable current, I can simply do calculations with this M only, right? While M is less than N, I'll keep incrementing my answer, and for all the other future iterations, I'll keep incrementing M with P. Finally, I can print my answer. So I hope this is clear. Can I move to the next problem? Okay. So the next problem is this overlapping sheet. So in this, we are given there are n rectangular sheets spread out on a coordinate plane. Now, each side of the rectangular region is covered by each side of the rectangular region covered by each sheet is parallel to x or y. So that means they are not placed in any angular in at any angle. Then specifically, the ith sheet covers exactly the region between AI to BI rows and CI to DI columns. You can look at that this way. And then we have to find all like the complete area of this coordinate plane, which is covered by one or more sheets. So if we look at this example, let's say these are the sheets that are given to us. So first of all, from 0 to 5 and 1 to 3. So 0 to 5, 0, this red box is that sheet, right? From 0 to 5 and from 1 to 3. So all the boxes in this area are covered by this red sheet. So finally, we have placed all the sheets and we have to calculate the area of all the region that is covered by sheets. So first of all, is the problem statement clear?
Yes, sir.
Okay. So now looking at the constraints, see, we have n, total number of sheets are n, and AI and BI are also up till 0. No, n is up till 100, and AI and BI are also up till 100, as well as CI and DI are also up till 100. So if we look at, first of all, tell me what is the maximum region that can be covered. Like what is the maximum value or maximum value of the row that can be covered? It can be this 100 only, right? Because no sheet is going after this. Like there is no sheet at 101th row, right? So maximum row that can be covered is 100, and similarly maximum column that can be covered is also 100. Why? Because there is no sheet placed at 101st column, so that's why we can only go up till 100th column and 100th row. So the maximum area that can be covered is 100 cross 100. So why not individually look at each cell? See, let's make a 100 cross 100 rectangular grid, and let's check for each cell. So assume that this is the 100 cross 100 grid. So let's first check for this cell, then for this cell. And what do I mean by check? We'll check for each and every sheet whether this cell, this current cell, is lying in any sheets area. And since we have only n sheets and n is less than equals to 100, our time complexity will be nothing but 100 cube. Why? Because total number of cells are 100 into 100, that is 100 square, and we are checking for each and every sheet. So that is 10 to the power 6. Now, first of all, is everything clear till now? Then I'll come to how to check this cell is whether this cell is in any sheet or not. But first of all, is the approach clear to everyone?
Yes, sir.
Okay, what about others? Like, can you just like simply write a yes or no in the chat? If you are having any difficulty in understanding this, just write a no.
Sir, can you explain time complexity once again?
Okay, see, maximum rows that can be covered is 100, maximum columns that can be covered is 100. So let's make a grid which has at max 100 rows and maximum 100 columns. So that grid will have 100 cross 100 cells, right? Cells of having one area, one unit area. This is one side length. So all there will be 100 cross 100 cells of one unit area in this grid, right?
Yes.
And now for each of these cells, I'll check whether this cell is in any of the sheets region. Like let's say there are some random sheets like this. This is one of these sheets, and maybe let's say this was another sheet. So I'll check this cell whether is it lying in any of the sheets area or sheets region. So there are at max 100 sheets, right? So for all these cells, I'm checking whether that cell is lying in any sheet or not. So that's why 10 to the power 6. Is it clear? 10 to the power 6 operations, right? So now how to check whether current cell is lying in a sheet or not? We can simply, let's say our current cell is I comma j. We can simply check if our sheets are like A, B, C, D, that is from this row to this row and from this column to this column. We can simply check if A is less than equals to I and A is and I is less than B. Why less than B? Because if you look at the example, our current, this is our zeroth row, this is our first row, this is our second row, this is our third row. So if you look at this, can I like just give me a copy image? I'll copy this image. Okay, so this is our zeroth row, this is our first row, this is our second row, third, fourth. So if I have to check for this cell, how will I check it? First of all, this rectangle is given to me by 1, 3 and 0, 5, right? I think this was what was given to me. It is 0, 5, 1, 3. So this rectangle is given to me as 0, 5, 1, 3. Can like someone just check quickly, like this is how it's given to me, right? 0, 5, 1, 3, and then it's 1, 4, 1 to 4, 0 to 5, okay, and then it's 2 to 5 and 2 to 4, 2 to 5, 2 to 4, yes. So this is given to me like this column is given to me like this, in this way. This is the column, this red column, okay? So this is how it's given to me. So now how can I check whether this cell, so this is my row start, this is my A, this is my B, this is my C, and this is my D. So how can I check this? If this is my second row, this is the value of my I, and my J will be 0 here, right? J is the column. So if my I is more than or equals to A and I is less than B, and if J is more than equals to C and J is less than D, then this current I comma J cell is lying inside the region of A, B, C, D sheet. So for this, I can mark this cell as in the final area that I have to calculate. Is it okay? Is it okay? Yes, no, anything?
Yes.
Okay, so I'll show you the implementation. So here I have taken first n as input, then I'm taking all the n sheets as input. So I'm taking A, B, C, D. Instead, instead of taking this, okay, yeah. Instead of taking this as a vector of array, you can take it as vector of vectors also, maybe a vector of pairs, or maybe a vector of tuples. So I have taken vector of array and I'm taking A, B, C, D as input. Then for these, I for all these cells, initially my f is 0. Now my f will be 1 if this condition is ever true, and it will remain 1 because I'm taking an OR. So what is the condition? If A is less than equals to I, B is more than equals to I, C is less than equals to J, and D is more than equals to J. Then I'll increase my answer by f. So if f is 1, then that means that this I comma J cell is in one of the it is lying in one of the sheets area. Finally, I can print my answer. So I hope this is clear. Can I move to the next problem? Okay.
Yes.
So coming to the next problem. In this problem, we are given that Takashi is planning an n-day train trip. Now, for each day, he can either pay a regular fare for a use of on each day, he can either pay a regular fare or use a one-day pass. Now, the regular fare for each of the I days is given to us as FIN. And we can only buy these one-day passes in a batch of D. So these are sold in a batch of D. We can only buy D or 2D or 3D, these 2D, 3D number of passes. And each batch of D passes is sold at PN. Now, we want to minimize the total possible cost for the n day trip. So first of all, we have n days, and for each day, we are given some FI values. For each day, we are given, let's say 2, 10, 3, 5, 7, 1, 3. So these are the values. On these, on the third day, we have to pay 3 yen as a regular fare. And other than this, we can also buy passes, and we can buy passes only as a batch of D. We'll get D passes, D number of passes for a cost of P. So now we have to minimize the total cost. So first of all, is the problem statement clear?
Yes.
Okay. So first of all, can someone tell me, if I'm not buying any pass, what is the total cost?
Sum of the FI.
Sum of the array.
Okay. So it is the sum of this array. So now, what is the next thing? I can take D passes, right? I can purchase D passes at what cost? At P cost. So if I purchase D passes at P cost, let's pay D is 2. D is currently 2. So what do you think, on which 2 days? This is first day, second day, third day, fourth day, fifth day, sixth day, and the last one is seventh day. So now tell me, if these two, which 2 days should I use these passes? Forget
Maximum one.
Second and fifth.
second and fifth. So you didn't actually wanted, you were not aware of this value P, but you directly told me that whatever the value of P, it's always better to use these on these days, on these 2 days, these passes. Why? Because in your mind, you calculated first, you had the sum. Now, if you are using 2 passes, the cost will be sum plus P minus these two maximum values, that is 10 and 7. So you, in your mind, you maximized this thing, minus 10 plus 7. So you maximized this thing, right? In your mind, because this is constant, right?
Yeah.
So on the next, if I'll again buy a pass, if I'll again buy two passes, then what will you pick? You'll pick 5 and 3, right?
Yes.
Yes.
And then you'll pick 3 and maybe 2, and then you'll again buy two passes. On buying two passes, you won't be able to use one of the passes, but you'll use the next pass too on this day. So basically what we are doing, we can check if, like, first the number of bought passes, let's say this is B, initially it is 0, my B will go from 0 to maybe while B is less than N. Then I'll try to buy, like, first I'll check currently, like initially I had the some value, then I'll try to buy those passes. So I'll buy D passes, and my sum will increase by P. Why? Because I have increased these many passes. And now for this D, like D times, what I'll do currently, like I'll check what are the maximum values available to me, and those maximum values I'll decrease from sum. So how to do this? Can anyone tell me how to pick the maximum D values that are currently available to me? How to pick this?
Set.
Yes, you can use a, not a set, but a multi-set. Why a multi-set? Because in problem statement, you're not 100% sure that all the values are unique. If you had only unique values, then you could have used set. But since the values are not unique, you should use multi-set. So finally, from like on each iteration, I'll pick the maximum value from my multi-set, I'll decrease it from my sum, and I'll erase that value from multi-set. Because on that day, on that particular day, now I'm using one of the passes. So finally, after, like, once this loop gets terminated, I can print my answer. Here, I'll also do one thing. My answer is minimum of, after each iteration, my answer is minimum of answer, comma, sum. Is it clear? Yes, no, anything?
Yes.
What about others? Is anyone having any doubt in this?
सॉर्ट करके प्रीफिक्स सम से भी कर सकते हैं.
Yes, like you can take that also, because like you can sort this and then you can take the maximum values. You can do right like that also. But is the idea clear? Like, is anyone having any doubt in this problem? Yes, no, anything?
No.
Okay, so I'll show you the implementation. So this is the implementation. First, I'm taking N, D, and P as input. Then these are the prices or the cost, regular fare for each of the N days. Then I'm inserting each of the values in a multi-set. And this is the initial cost if I don't buy any of the passes. So this is just the sum of values in vector F. So initially my answer is this val. Then I'll keep on buying these passes while my B is less than N. So I have bought these D passes. My value has increased by P. Then for D times, I'll iterate through this and I'll remove the maximum value that can be removed from my multiset. I'll decrease that value from val. And finally, I can take answer as minimum to be an answer of this, either answer or value, this val. So is it clear?
Yeah.
Okay, so let's move to the next problem. So coming to this problem, in this problem, we are given that we have a weighted, undirected, complete graph with n vertices numbered from 1 to n. Now the edge connecting vertices I and j has a weight of dij. Now, when choosing some number of edges under the following condition, we have to find the maximum possible total weight of the chosen edges. The endpoints of the chosen edges are pairwise distinct. So first of all, let me explain the problem statement. See, we have n vertices, and a complete graph means that every vertex is connected to every other vertex. So something like if I have n as 4, I'll get something like this. If I have n as 5, I'll get something like this. Okay. So first of all, is this clear? What is a complete graph? Every
Can you
vertex,
explain once again?
like your voice was not clear. Can you repeat yourself?
Like strongly connected component stuff or something else?
Okay, no. Strongly connected components is different thing. Strongly connected components comes into scenario when you have directed graphs. This is a complete. This is an undirected complete graph.
Okay, like
Strongly
okay,
connected
got it.
component in an undirected graph.
What
And
is asked?
yes.
What is asked in the question?
Yes, I'll come to it. But first of all, is complete graph. First of all, what is a complete graph? Is this clear to everyone? If we have n vertices, then a complete graph of n vertices is nothing but every vertex of this graph is connected to every other vertex. So first of all, tell me how many edges there will be in a complete graph of n, of size n, of a graph which is having n vertices. How many edges will there be?
NC2
NC2. What is the value of this NC2?
n into n minus 1 by 2.
Yes. So no one should be having a doubt in this. NC2 is nothing but number of ways to select any two vertices out of these n vertices. So if you're like select any two vertices out of the n vertices and connect them via an edge. So this simplifies into n factorial divided by 2 factorial divided by n minus 2 factorial. So this n factorial is nothing but n into n minus 1 into n minus 2 factorial. This is 2 into n minus 2 factorial. So this gets cancelled. So you are left with n into n minus 1 divided by 2 factorial, which is 2. You can also look at you can also look at this like for the first vertex, you have to connect it with n minus 1 vertices. For the second vertex, you have to connect it with n minus 2 vertices. Why? Because 2 is already been connected to 1. So all the way up till 1. So sum of this thing is sum of 1 to n is n into n plus 1 by 2. And since you're not going up till n, you're going up till n minus 1. So just substitute in place of n, substitute n minus 1. So you'll get the same formula, n into n minus 1 by 2. So this is okay. We have a complete graph. We have a complete graph. We have a complete graph. And now for each of the edges, n is like, I think it's only up till 16. Yes, n is only up till 16. And we have a complete graph. And for each of the n into n minus 1 by 2 edges, n into n minus 1 by 2 edges, we are given what is the weight of that edge. So assume n is 4. So this is the graph. And we are given for each of the edges, what is the weight. So now we have to find what is the maximum number of edges that we can select. What is the maximum number of edges we can select such that no two edges share an endpoint. So first of all, if no two edges are sharing an endpoint, what does this mean? Anyone? If no two, like we have to select the maximum weight of edges, like maximum weight. This should be, we have to select some edges such that their weight, we have to select some edges such that we have the maximum weight, and no two edges should share an endpoint. That is a vertex. No two edges should share an endpoint. So first of all, what does this mean, endpoint? So just like if you are able to understand what this means, you'll be able to solve the problem. What does this mean? No two edges should share an endpoint. It means that if this vertex, if I have chosen this vertex and this vertex, like this edge, then these two vertices cannot come again in your selected edges, right? Because if this vertex is coming twice, then by default, this will be connected to two edges in the final selected edge. Like in final, all the selected are, finally, when we have selected all the edges, then if this vertex is coming twice in those edges, then these two edges share an endpoint, right? Yes, no, anything?
Yes.
Yes.
So
Like from every vertex, we can choose only one edge.
yes. From every vertex, we can only choose one other vertex to connect to it. Or simply put, from every vertex, we can only select one edges that is connected to this vertex. So now we are given that there are only 16 vertices. So one of the ways to solve this is using DP. So what will be the state? See, DP of I will be having some mask. And I'll tell you what this mask is. But this value will give us the maximum weight of edges, given that if, like, let's say this mask will have n bits. So let's say this was the mask. So if I have selected these edges, like I have selected these vertices already. Now these vertices cannot be again connected to any other vertex. I have already removed, like you can assume that these vertices have already been connected either among. Now you might say, why in this example I'm taking 5 as the number of vertices, because I can only connect 2 vertices, right? So this, you might think that the number of ones in this will always be even, but that is wrong. I'll show you an example in a moment. But first of all, don't worry about this. Just see that this mask is giving us that all of these ones represent that the vertex. This is 0, 1, 2, 3, 4, 5, 6, 7. So this means vertex 1, vertex 3, vertex 4, vertex 6, and vertex 7 have been already connected to an edge. So we cannot connect these vertices further to any edge. And after this, DP of mask of this will give us, once we have achieved, like once we have this position, once we are at this position, what is the maximum weight that we can get after this? Maximum weight of edges. So what we can do, we can either connect these two vertices because these haven't been connected. We can either connect these two, or we can either connect these two. So there are still possibilities, right? So we'll check maximum of these possibilities and we'll return that as the value of this. Is this thing clear, first of all? Like, you can ask me doubt if you're having any doubt in this.
Like, can you show one transition?
Okay, yeah, I'll show. Other than this, is there any other doubt?
मतलब हर बार 16 स्क्वायर का इटरेशन लगेगा.
Yes, the total complexity will be something around 2 to the power 16 into 16.
लेकिन दो बिट का चेक करना पड़ेगा तो 16 स्क्वायर.
No, like I'll show you how. Even if you multiply this by 16, I think the value, okay, let me see this. I know this will be approximately equals to 10 to the power 6. You can verify this one. This is 10 to the power 6. I know this. This will be like, this is close to 10 to the power 6, not exactly 10 to the power 6. If you multiply this thing again with 10 to the power 6, you will land up with something 10 to the power 7. So this will also work.
और वो सेट बिट ऑड कैसे हो गया, मतलब ऑड में कैसे check?
Okay, yes, I'll tell you. See, you have to finally maximize the weight, right? You have to finally maximize the weight. So let's look at this example. 10, 1, 1. So in this scenario, n is 3 and it's optimal to select just this edge. So if you're selecting just this edge, you'll get the maximum weight as 10, and the vertices, let's say this is 0, 1, and 2. So in this case, the mask will be 1, 1, 0, because this vertex never gets selected. So that's why this remains 0. So in a more complicated example, it's possible that one of the vertex gets leaved out, right? You're not connecting it to any other vertex, right? Yes,
Okay.
no, and
Yes.
okay. And now coming to the first, like, let's see and transition, like how these transition work. So I'll take this example only. See, so these were the vertices, and my vertex 1, these are the vertex number. These vertex have already been selected. Like, I cannot select these vertices. Either I have selected these vertices or I have skipped these vertices. That's why I'm getting 5. Like, 2 of these would have been either connected, like these two pairs might have been having an edge between them, and I've simply skipped these vertices. I've decided that I'm not going to connect this vertex to any other vertex. Now I have to find what is the maximum value that I can get. So how to do this? See, first of all, I'll find a bit which is 0. First find a bit which is 0. Index, first find a index where the bit is currently 0. That means it is unset. So let's say we found this thing. You can always look for the first bit and then either just make your mask or like just set this bit. Let's say this was I, first unset bit. Just like call this thing without adding anything, like without adding this vertex to any other vertex. So that means I'm not connecting this to any other edge. So in that case, my mask will get updated like this for the next time. With the value, I haven't connected this vertex to any other edge, right? I'm just simply removing this. You can also see it like that. Are you getting why I'm doing this thing? Yes, no, anything?
Here we are ignoring this one.
Yes. We are ignoring this vertex. Like here we ignored this vertex, right? We didn't take this into account. Like we are not trying to connect this vertex to any other vertex. This will be left out. We are trying to, like, these two are connected to each other, but this is not connected. So here, first of all, find an index which is having unset bit, and then for that vertex, first take that case into consideration when you're not connecting that vertex to any other vertex. So is this thing clear?
Yes.
And now let's say I have another j, and my j will iterate from, now my j will iterate from 0 to n minus 1, and I'll check if my mask and one left shift j, if this thing turns out to be 0, that means that the bit is not set in mask, right? This vertex has not been selected till now, right? And of course, j is not equals to I. Like I'm trying to connect ith vertex to some other vertex. So first of all, j should not be equal to I. You shouldn't connect the same vertex to it. So then, and
Then we can run from I plus 1.
no. Like I said, it's possible. Okay, yes, you can run from I plus 1 because there is no point in checking previous vertices. Why? Because they are already skipped or they have already been connected. So you can start your j from, instead from 0, you can also start from I. So, but it won't have that much difference. Like the number of operations will decrease by significant, but the overall time complexity will still remain same. So now if this thing means that this jth vertex has not been chosen till now. So then what you can do, you can connect this I and j vertices together. Now dp of mask will be nothing but equals to maximum of, now this thing, like dp of mask again, dp of mask, and what will be the other thing? Other thing will be h cost, that is d I to j plus solve. I'm again recursively calling my function solve, and mask. In this, I and j are both removed. So first I'll take one left shift I. So I'll set this bit also, and one left shift j. I'll set this bit also. Finally, I can return dp of, I can return dp of mask. Is it clear? So this will be my result. Is it clear? Yes, no, anything?
Yes.
What about others?
Here in the solve, we are setting the bit and calling the function at the
Again,
same time, isn't
yes,
it?
yes. Here we are doing both the things. For the next iteration, I'm updating this mask. So we are calling this function, and with the updated mask, which is we are setting these two bits in mask. Is it clear?
Yeah.
Okay, so I'll show you the implementation. So this is the implementation. In this, I'm first taking like these values as input. So if I and j, like the value is given to us that the edge weight between I to j, and similarly, like if it is undirected, I can take the edge as j to I also. So that is this temp. Okay, I've taken temp as input here. Then dp of like my mass can be maximum 2 to the power n, which is 16. So initially everything is -1. Then here I'm calling solve of 0. Now what will happen here? If mask plus 1 is already equals to 1 left shift n. So that means mask plus 1, simply this means that every vertex has been chosen. So I've considered all the vertices. I'll simply return 0. Otherwise, if dp of mask is not equals to -1, this means that I have already calculated the answer for this value earlier. I'll return that value. Otherwise, I'll find the first unset bit. So you can also use inbuilt C++ function, but I haven't used those. So here I'm finding the first unset bit. Then if there is no unset bit, I actually don't have to check this, because if there is no unset bit, then I would have returned simply from here. Then I'm checking, I'm calling that case dp of mask is, I don't have to take maximum also, because I'll never get value less than 0. So dp of mask is solve mask or, and selecting this. Then for j from 0 to n, I can start from I also, and can start from 0 also. So if j is equals to I, then, or if mask, like if this bit is already set in mask, then simply continue. Otherwise, dp of mask is maximum of dp of mask, comma, if I add this edge, like if I select these I and j together, they will be connected, and mask the selecting these two bits in mask, finally returning dp of mask. Is it clear?
What if I or j are some neighbors of some visited vertex?
Like, give me an example.
Like that I and j are all, neighbors of some set bits.
So I and j are some connected to some third vertex k, and k has already been selected. You are seeing this.
Yeah.
So I and j are still like we have a complete graph. So every two vertex are connected, right? So we can still select this as the edge, and these two edges wouldn't have been selected. Even if this vertex is selected, these two edges wouldn't have been selected, because if any of these two edges would have been selected till now, then neither, like both of the bits representing I and j shouldn't be 0, right? So how did I found I? I found I by checking the first unset bit. So I made sure that this vertex has not been selected till now. And how did I got j? For j also, I'm checking that this is not currently selected. So that's why these two vertices have not been selected. Maybe k is selected, so there is no point, right? Maybe this vertex was selected, this edge was selected. So that's why k is selected. I'm selecting this edge now. Earlier this was selected. Is it clear?
Yes. Can you show code once?
Okay. Like I think someone other than you asked this problem. So is it clear to that person?
Yeah. What is the importance of this complete graph now?
Okay. The importance of complete graph is that every vertex is connected to every other vertex. So I'll simply go for I will simply go from 0 to n, because there is an edge from I to each of these vertices. So I can just check that whether or not this vertex has been selected, this vertex has been selected, this vertex has been selected. And if, let's say, this vertex was not selected, then I'll try to connect these two vertices, select this edge, this particular edge, and find the maximum value. So the completed graph means that every vertex is connected to every other vertex. So I can check for each and every vertex. Like for connecting this vertex, I can check for each of the remaining vertices, which are currently not included.
Okay. नहीं तो adjacency list से करना पड़ता.
Yes. Otherwise, we'll have to make an adjacency list. If we weren't given that complete graph, then instead of iterating from 0 to n, I would have made a adjacency list and then checked. Then also, like after making the adjacency list, then still I would have to check whether this jth vertex has been already included or not. But yes, then there was no point in going, like my j wouldn't have gone from 0 to n.
Yeah, clear.
Okay. So this is the code. Anyway, I'll share the code after the session. Is it okay? So should I move to the next problem?
Actually, I have a doubt.
Yes, yes.
Like, if there are like multiple zeros in the mask, then like we should go like
If
why
there
we
are,
cannot n square?
why is it not?
Like n square. Like we for one transition we are doing 2 zeros to one, right?
Yeah, these two. So this is n plus n. This is not inside this loop, right?
No, but like for every 1 0 we can choose all other zeros, right? It's like it
Yes.
should not be inside.
So, but finally, like you won't calculate more values than your mask is representing it. You cannot calculate more than DP values. So DP is having size of mask. Mask is nothing but 2 to the power n, 2 to the power 16. And you're having you are iterating for each of these, you're iterating 16 times. Plus, like there will be some factor because of those OR operations.
No. Actually, my doubt is that it should be like the loop should not be inside
Which loop?
the two for loops, like for selecting 1 0 and the selecting second zero.
Yes. So, okay, this is like not selecting 1 0. This is always selecting the first unset bit. This is
Oh,
selecting
okay.
always selecting the first unset bit. Yes, not any unset bit. This is
Okay.
selecting any unset bit. This is selecting always the first unset bit. Is it okay?
Okay. Yes.
Okay. So let's go to the next problem. So in the next problem, we are given that we have a sequence of positive integers a1 to an, and we have to find the number of triples of positive integers ijk that satisfies these conditions. So first of all, I should be less than j and j should be less than k. Then ai and ak should be same, and aj shouldn't be equals to ai. So by default, aj shouldn't be equals to ak also. So this is a simple problem. Like we just have to, let's say we have something like this. And now assume that there are some values here. So let's say some one is appearing here, one is appearing here, one is appearing here, and then one is appearing here and here. So first of all, these values are not equal to 1. There are some other values. So first of all, let's iterate only over the positions at which 1 is there. Okay. So how can I calculate the answer when, see, finally I have to calculate the pairs or triples which satisfy this condition, right? AI is equals to AK and AI is not equals to AJ, right? So I have to satisfy this thing. So what can I do? See, if I'm only iterating over these positions, this is the positions of ones. So just give me a second. Okay. So if I'm only working at the positions of the ones, then what should I do? See, can anyone tell me what will be the answer if I is this and k is this? What will be the answer? Like how many j's can I get? Basically, I'm asking you how many j's I can get if I select I as this and k as this.
One.
Yes. Why? Because this is the j at which the value is, this is the j at which the value is different than I and k, and this j is between I, like it's more than I and less than k. So that's why there is 1. Then this is like how, okay, I will come to the calculation parts in a moment. But now if I come to this place, how many, like these should be added how many times? These values.
3.
Why 3? Like
Means
these
okay. So
2 times, right?
yeah, 2 times.
And this should again get added. And this shouldn't get added. So basically, this is, if you look at this, what we are doing, let me just write the pseudo implementation. First, let's say we are iterating for ones. So first, let's say there is a previous variable. Previous will hold the position of, let's say, what is the position of 1 and what is the first position of 1. So this is giving me first position of 1, right? Now what I'll do, I'll simply check for like int, let's say I'm iterating through complete. I'll start from the first. This was the first position. I'll start from second position of 1. So that's why j is 1. This is like the index 1, and j will be less than position of 1 dot size. Like position of 1 is having how many, like all the indices at which I have 1. So position of 1 is having all the indices at which there is 1, at which the value is 1. Okay, so now position dot 1 dot size and j plus plus. So after this, I'll have to just simply add. So what is the thing that I'm adding? I'm adding answer plus equals to j times. Why j times? Because as I said, first time I added this once, second time I added it twice, right? So this is the first index 1, this is the second index 1. So I'm adding j times position of 1 comma j minus everything which is previous. Like this was, see here by default this is at 0, but let's say there are some previous characters also, previous indices also. So basically I'll write this again. I'll write the complete thing again. See, if you look at closely, if I have 1 here, 1 here, and 1 here, so in order to calculate all the places between these, I'll add the position of this ones, position of this 1, let's call this as position dash of 1 into 1 minus the position of this thing, right? Let's call this as position not of 1, right? These are the, if you minus 1, why minus 1? Because you have to decrease this also, you cannot take this. So j's are this thing, right? Is this clear? First of all, these are the number of j's that are between these two, right? Position dash is the position of this thing.
Sir,
Position, yes.
actually, I am not understanding problem statement. Like,
Okay. You just have to, if you're given an array A, you have to count how many I less than j less than k. How many triplets of like this you have such that AI and AK are equal and AI is not equals to AJ. You have to count all these pairs, right? Is it okay?
yes.
And now how to, like, just ignore all the values right now, just consider all the ones. So let's say these are the ones. So consider that this is position not, this is position dash, this is position double dash, right? So how to calculate all the j's that are between these two places such that if this is my I and this is my j, those conditions will satisfy. What are the conditions? I less than j less than k, and AI is like this condition has already been satisfied. AI is equals to AJ, right? But AI shouldn't be equals to AJ. And this is already true because if these elements were also 1, I would have written 1, but these elements are not 1 right now. So these are innate. So how to count these two? This is nothing but position dash into 1 minus position not, right? Minus 1.
Okay. Yes, got it.
Okay. And now how to calculate all the places, all the values between these two? How to calculate these two? Like how to calculate all the j's if this is my k? Like if this is, actually this is not j, this is k. Now earlier this was I, this was k. Now if this is my k, how to calculate? Now my calculations will be position double dash into 2 minus position not minus position dash minus 2. Now let me tell you why this is. See, this is because I can break this into two parts. First of all, I have written position double dash minus position not minus 1. And there is also minus 1. So I'll tell you what this is. But and the second thing is I have written plus position double dash minus position dash minus 1. So this thing is clear. This is the same as this thing, right? So this is basically, this term is this second term. This second term is
डीपी जैसा है कुछ.
kind of, so this second term is this thing. the number of j's between these two, right? This thing is same, right?
Yes.
And what is this thing? This thing is actually, like, this is not actually DP, this is just observation, and I think it's just mathematics.
But on
Position,
direct we कर सकते हैं.
like I'll show you the implementation, is direct only. So position double dash minus position not is calculating number of j's between these two. Like if you look at this value, right? What is this? This is calculating number of j's between these two places, right? Right? Are you getting this thing? Like this value is this thing, right? Yes,
Yes.
no, anything. But I cannot select j as this value. Why? Because j shouldn't be equals to I. So that's why I'm subtracting -1. So what is the formula? What will the formula be? Position into j minus, this is the sum of all the previous values, minus previous minus j. So you keep doing this for your all the positions values. For first you do this for position 1, then you do this for position 2, like all the position in which you have 2's, and you can only get, like, you'll only go up till n. Why? Because the maximum value in your array is n. This thing, this thing. So this is the formula, and like first assume that your value currently I is going from 1 to n. Then inside this, what will you do? Initially your previous is position of I of 0, that is the first place. This is your I. Then your j will go from 1 to position of I dot size -1, I dot size -1. And what will you do in this loop? You'll add answer plus equals to j times position of I comma j minus all the previous values minus j. And now you'll keep adding previous plus equals to this position of ij. So if you write this down, this is really simple, but because if this is my k, then what are all the position of j's? If this is my k, what are all the positions? So if this was k, these are all the positions of like valid j positions. If this is your k, this is your valid j positions. So if I break this down, this is nothing but these two things. Is it clear? Yes, no, anything?
Code.
Yes, I'll show you the code, but first of all, is anyone having any doubt in this?
No, it's clear.
Okay, like I can write, if you want, I can write for one more one. Should I do this? Okay, so let's write this down. Like it will be much more clear then. So if I, by formula, I'll get, first of all, let's write, first of all, tell me what will I get using the formula? Let's call this as position triple dash. What will I get? I'll get,
minus.
yes, I'll get position triple dash into 3 minus position double dash minus position single dash minus position not minus 3. Now, actually, this is the complete thing, but how to break this down? What is this actually representing? This is nothing but, this is, if I write this is first position triple dash minus position double dash -1. Then it is also position triple dash minus position dash -1, and then again -1. Then it is position double dash triple dash minus position not -1 -2. So first of all, this thing is clear to us. What does this thing mean? This thing means the number of j's between okay, the number of j's between these two places, right? Is anyone having any doubt that this is number of j's between these two places, number of possible j's, right?
Yes.
And now this is the number of j's between these two places, but extra -1. Why? Because this is extra -1. This is number of j's between these two. Why -1? Because of this thing. I cannot select this as my j, right?
Yeah.
And then what is this thing? This is nothing but the position of j's, valid j's between these two places. So this is okay. This is number of valid positions of j's between these two. Why -2? Because I cannot select j as these two. So now is it clear?
Yeah.
Okay. So I'll show you the implementation. So this is the implementation. In this, I'm first taking n as input, then I'm taking array A as input. Then for all the values, I'm inserting the indices of those values in a position vector. So these are like for AI, I'm getting it at index I, so I'm inserting it in position. Then I'm calculating my answer as if, like, first of all, if there is no element I in your array A, so there will be no position of it. So if there is for position I, the vector size is 0, then I'll simply continue. Otherwise, my previous is position of I 0. Then start from 1 to, and I'll go up till position I dot size, and each time what I'll do, position ij, that is this index, like the value of this index into j minus previous minus j, and I'll add position of ij plus j into, and why I'm adding j here also, can someone tell me why I'm adding j in previous also? Anyone? Because see,
Previous will be shifted to next.
what?
Previous will be upgraded by J position.
Like, yes, yeah, that also. And see, if initially this is my previous, like previous is having values up till this point. Now, if I add this also, and if you look at here, see here I have decreased j because here I would have decreased j because of these, like all the values that were coming in this part. But now in future, when I come to this, then also these won't satisfy for this value, right? Like these will never satisfy for any of the values that are coming after this, right? Yes, no, anything?
Yes, yes.
So that's why
Yes.
that you have to add that j to previous, because it keeps getting decreased. That will never be, like those places can never be considered as valid j options. So I hope this is clear. Like you'll have to write this down. Like this is not a very difficult problem, and maybe like if you implement this on your own, you'll be able to implement it in a much cleaner way. It's just simple mathematics. Like I won't say this is actually DP. Like you can maybe solve this using DP also in an easier way. But the thing that I have implemented, I don't think that this is DP, because I'm not using any previous values. Like I'm using this prev only, but this prev is nothing but it's kind of prefix now. So anyways, try to implement this on your own, and that's it for today. And thanks for joining. Okay, if in case if you implement and you find that your code is not working, so raise a query and
Will
we'll
you
try.
share the code?
Yes. So managers, after maybe within 1 hour, you'll get the codes plus the recording.
Actually, where we can find these codes?
You'll get the codes like in the YouTube, if you'll check in the description of the YouTube video.
Oh, thank you.
Okay, so thanks for joining. Bye bye.